There are multiple ways accumulation functions can be represented, and this here is the analytical representation, which tells us that the area under the curve of the function f from a to x, so for example if a equals 2 and x is anywhere, then this is the area that keeps accumulating as we move x to the right. So effectively what we'd get is g of x minus g of 2. And for the special case where the function evaluates to 0 at a, then we can get rid of this term. So this is the graphical representation, and we can also have numerical representations. So in this case we can actually calculate the area under the curve from 2 to x using the area of a trapezium. So taking the average heights of the trapezium, and then we multiply by the width of the trapezium. And that'll give you a general expression for g of x. And this is the same as the area that'll be given by the definite integral, and we'll show that when we learn how to evaluate definite integrals. And you may also get accumulation functions as verbal or worded problems.